Morning, and thank you for joining us for a live talk today with STEM Ambassadors Sam and Daniel from the CAA. The Civil Aviation Authority is the statutory corporation which oversees and regulates all aspects of civil aviation in the UK. It's great to see so many of you joining us, and we're sure you'll enjoy this webinar. To celebrate World Space Week, Daniel and Sam will give you a brief insight into satellites from spaceports to rockets to space. And please feel free to ask any questions by putting them into the chat, and the guys will aim to answer as many as they can at the end of their talk. So that's enough from me. I'm going to hand you over to Daniel. Good morning, Daniel.
Hi, thank you very much. Hi everyone. Thanks for joining this morning. I'm Daniel Innes, and joined by Sam Frampton, and we're going to talk through satellites, so from spaceports to rockets to space. So very first, I'm going to talk about me, just really quickly. Why is it me that's in front of you today? I'm a launch systems engineer at the CAA, as I said, and what that means is that although in the title we talk about launch systems and I talk about rockets, and that means in part of my job it's around designing rockets and reviewing rockets, and similarly with spaceports, our job really focuses around public safety. So it's making sure whatever we're doing in the UK with regards to launch operations, that public safety is really at the heart of that, and that's what our team does. I have a degree in mathematics. I came through school loving physics, loving maths, loving science, loving astronomy, and wanted to pursue that as a career, and went on and did maths, and then continued and did space engineering after that. And that led me on to a career where for the last 4 or 5 years I've been helping design spaceports and rockets throughout the UK, and there's quite a few in development, and I'll show you those in a second. But yeah, fortunately I'm position myself to be able to work on quite a lot of those. And from all the pictures on the right hand side, although these rockets are a little bit smaller than the ones we're going to be talking about today, I helped build and launch a lot of these rockets, and I've launched over 30 of them. So that's all great fun as well, and ran a lot of small events where children and students were able to come along and launch these rockets. So that's a little bit about me. Today we're going to talk about this journey. So this is the satellite journey, and the satellite journey typically starts back in an integration facility or a clean room, and there's the design and the build of the satellite. When the satellite's built, it'll move on to a spaceport. It'll be integrated in with the launch vehicle or the rocket, and when the satellite's put inside the rocket then launches. After the rocket's launched, the rocket fires the satellite at the top of the rocket in space, and the satellite is operational whilst it's in orbit. There's then some data processing. We get all the good stuff out of the satellite. The satellite has communications, it can take images, there's different purposes for different satellites, and there's a form of data processing, and you get the applications from the satellite after that. And then there's the satellite's end of life, where it no longer is needed to be operational, or no longer can operate. And Sam's going to talk a bit about the satellite side of things, and I'm going to stick to talking about the spaceport and the rocket side of things. We'll also try to answer the question, well, what does the CAA actually do? What do we have to do with space? And what career opportunities are there in space as well? I'll touch on those towards the end. So first, what is a spaceport? That's near the start of the journey in terms of getting a satellite into space. So a spaceport is a site for launching or returning a spacecraft. In the UK, you can think of a spaceport not as being like what you would maybe picture in the US, where it might be a massive big site with lots of launch pads and these huge big massive NASA vehicles. That's not the type of thing that we're doing here in the UK. It's on a much smaller scale, and when you look at them, they may still look like relatively large rockets, but they're classed as small rockets in the UK. The UK are focused on small rockets, small satellites, and we have very small and very minimalistic spaceports. So kind of the minimum amount of things that we need there to actually just make the launch happen. Launches can happen many different ways though. So it's not just the typical vertical launch that you might see where the rocket just goes straight up into the sky. You can actually launch a rocket horizontally as well along a runway. You can strap it to a large Boeing 747 or some form of carrier aircraft, the carrier aircraft can take off along the runway and then drop the rocket at some point in at altitude. The rocket can then ignite and it can take off from within the sky. And that's we've actually licensed one of those launches already for down in the south of England. And then there's balloon launches as well, and you can get a large balloon that fills. You just think of it as filling with helium. You can take a rocket up to an altitude and then drop a rocket, and again can ignite whilst it's in the air. And there's multiple advantages and disadvantages of doing launch like that. But yeah, launches, you get loads of different sizes, you get different types of propellants, there's loads of different varieties and types of launch vehicles, and that's why you get lots of companies all wanting to build different types in order to launch them in the UK. You can also land the rockets, as I said, spaceports for landing rockets too, and they can land vertically, like you may or may not have seen with people like SpaceX, who are starting to land some rockets and land some boosters of rockets, and there's some cool YouTube videos out there on that. And you also get horizontal landing, so the more space plane type landing, where a plane will glide back and land on a runway. At spaceports, you can test rocket engines too. Okay, what spaceports are there in the UK? Well, there's one official licensed spaceport currently, and that's down at the very bottom, called Newquay or Cornwall, and that's a horizontal spaceport. The other ones are all somewhat in development. They have been for quite a while, and they're either at the design stage or they're at the construction stage. And the ones further up north tend to be more vertical launch, as you would picture them, with a vertical rocket taking off straight up the way. And these ones are all somewhat in construction now, actually, and quite close to becoming operational. It's exciting that all this is going on, and there's a right variety of spaceports throughout our UK. I have a quick video here to play it on the type of rocket launch that we can expect in the UK in the next few years. As you'll see, it's a relatively small spaceport. It's a relatively small launch. And you can see that this launch is happening in a large sort of fielded area. It's out in you can see the coast, the sea in the background, and I think this is a relatively small rocket as well. And this is the type of thing that we can expect in the UK. We can expect it to be an unpopulated area, and hopefully in the middle of nowhere, and you can expect it to be close to the sea, so that after it starts to go upwards, it can start to head over the sea. Okay, well, what is a rocket? I've spoken about a spaceport and you've just seen a rocket launch. What is a rocket? A rocket is just a way to get that satellite that we're talking about into space. So it's quite amazing that actually that satellite we're talking about is only about 1% of the rocket. It's a very small piece of material at the very top of the rocket, and almost all the rest of that rocket is just designed to transport that little thing up into space. And about 90% of that is just the fuel. So you can get a solid fuel, which is sort of a hard rubber. You could even hold it until something ignites it, and then at which point it becomes a bit more dangerous. But you can get solid fuel, or you can get liquid fuel. Liquid fuel is typically like a liquid oxygen, an oxidizer, mixed in with a fuel that's a bit like the fuel you put in your car. And if you mix those two together, and again you ignite it, you get another form of propellant. And that's exactly what you've seen in the previous video there. That was a bit like your fuel you put in your car, mixed with an oxidizer. You just light it, and that gives you your propellant. But it's quite amazing that really the majority of that rocket is just stuff just to get you into space, and that's the purpose of a rocket. This rocket on the right hand side, this black one here, this is a rocket from Orbex, who are currently producing this up in Scotland, and this launch pad here, or this test pad, is up in Kinloss near Inverness. I think that's the last thing to say here. I would like to just touch on what sort of size is the rocket before I hand over to Sam. And here's a little comparison. So this shows you the comparison of rockets, and this large rocket is a SpaceX Falcon 9 rocket. The SpaceX have done many launches with this rocket, and it's very successful, very reliable, but it's massive. It's 70 meters, and it's still not even the biggest rocket if you look at some of the NASA ones. The types of rockets that are going to be in the UK, are more these anywhere from around about the 18 meters up to the 25 meters ish. So these sort of three that are right in the middle, that's the size that we're looking at. And this Launcher 1 rocket was the one that was launched recently or earlier this year down in Cornwall that unfortunately had a failure. So I think that's everything I wanted to talk about. That's just a very broad overview of spaceports and rockets, not going into a lot of detail at all, but I'm more than happy to answer any detail in the questions at the end. And I'll hand over to Sam now, who can talk a little bit more about satellites.
Thank you, Daniel. Hope everyone can see and hear me. Yeah, so as Daniel mentioned, the bit on the end of the rocket, satellite, is what I'm going to talk about. It's small, but arguably it's the most important part. But before I get into that, I just want to talk a little bit about me. So I'm from Portsmouth originally, always been interested in physics, did my A-levels in physics, maths and biology before going to study physics at uni. And it wasn't until actually after university that I realised how much opportunity there was in space in the UK. So I kind of changed track and went on to do a master's in space engineering, satellite design, and going on to look at actually what is on the top of the rocket. And that's brought me to the CAA, where I work as a mission safety analyst in Dan's team. Next slide, Dan. So yeah, we're talking about the bit on the end of the rocket. So when we think about satellites, the ones that we often hear about are the big kind of telescopes, the big space missions, the ISS, all these really, really big missions that get put on the end of the rocket. So on the right here, I've got a picture of the James Webb Space Telescope, which if you've seen pictures from space recently, it's probably been from that, the most powerful telescope we've ever put into space. And you can see there, part of the team that designed it are standing next to it. You can just see how massive the thing actually is. And then in comparison, on the left, what we have is what we call a CubeSat. So you can see the hands there, it's about this big. And that's a functioning satellite. You can put cameras on it, you can have things that study space, you can have things that study the Earth. But we put that on the end of rockets and we launch it into space and they work. And there are small teams across the UK and across the world who are building satellites of this size. You know, universities, student teams, small companies. Everyone's getting involved. So, you know, back in the Apollo era, when we were putting people on the moon, space was really only for big governments and people with big budgets. But actually now what we see is more and more people are getting involved and more people are doing things in space. Next slide, Dan. So I've got a brief video here just to talk about, well, okay, there's a lot of people putting things into space, which is good. Space is useful. We need to use space to find maps on our phone, in our cars, we need it to make calls. But the issue is that actually as more and more people are putting things into space, it's getting more and more congested. And space is big, but actually there are only certain areas of space that are useful for us to use. So what you see here are these dots getting more and more populated as the years go on. And the issue with this is that if all these satellites are in the same space, occupying the same orbits, you can get into a position where they start crashing into each other. And that's a real problem, because when these things are in space and they crash into each other, they explode out into lots of tiny bits of debris. And these bits of debris can then stay in the orbit and they whiz round at tens of thousands of miles an hour and they can hit other satellites. And then if a bit of debris hits that satellite and it breaks into a debris, that bit of debris hits another satellite, breaks into another debris, you get this rolling on effect. So yeah, there you go. You've got some estimates on the video there. About 34,000 objects greater than 10 centimeters in orbit. And the ones smaller than 10 centimeters, we can't see at the moment from the ground. We don't have a way to measure them from where we are. So we know that there's lots of tiny flakes of metal and bits of debris up there in space, but we don't know exactly where they are and we can't really track them. Next slide, Dan. So yeah, I originally had a clip from the film Gravity, but I didn't want to get done on a copyright. So I've just got a screenshot here, but if any of you have seen it, you know, you've got an idea of that. We've got these bits of debris whizzing around and they really come fast. And what you start to see is that, you know, we have astronauts on the International Space Station and they're relatively low in orbit. So let's say they sit about here, if you can see my hand, and just above them they've got all these bits of debris whizzing past. But over time, these bits of debris slowly start falling back towards Earth. So what you start have happen is that those bits of debris can go past where our astronauts are. So the ISS has been designed to withstand some of these impacts, but it has to move to avoid some of these bigger bits of debris, and that's something that happens all the time. And as we launch more, as we have more constellations, as we have more uses for satellites year on year, this is only going to become a bigger problem. So when we're looking at debris, we have to have a way to deal with it and a way to sort it. So next slide, please, Dan. What can we do about it? There's kind of two schools of thought on this. So what we do at the CAA, as having safety and sustainability as our concern, is we look at the people who want to build and design these satellites. We ensure that they know what they're doing, basically. So on the left, we've got the OSIRIS-REx mission, which went to go visit an asteroid, and it's a picture of some of the team there doing on-ground testing of the satellite. So before you launch a satellite, you really want to do a lot of tests to make sure that the thing is going to work how you expect it to, right? Because once it's up there, you can't really go and fix it. If something goes wrong, or you can't communicate with it, or more dramatically, the thing just blows up in space, that's it. You can't go and fix it like you can on a car. You can't go have an MOT in space. So we've got to do all the testing on ground, really put it through its paces to make sure that the thing works. And they'll put them on these big vibration beds, which are basically big metal plates, stick the satellite on top, and you shake it, and you really, really shake it, because as you saw in Dan's video, on the launch, you've got this big firing rocket underneath you. That's really going to shake the satellite. And if you're not ready for that shaking, the thing's going to fall apart. So that's what we do. We try and make sure that people know what they're doing before they get to space. And at the moment, what people are developing are actual debris removal missions. So the picture on the right is a computer image of Clear Space 1, which is a proposed debris removal mission. And this is actually launching another satellite up into space that has the ability to grab bigger bits of debris. There's a big long list of pieces of debris that we think are going to be particularly problematic. And there's plenty of companies at the moment that are looking at ways that we can actually grab these pieces of debris, bring them back to Earth, and they'll burn up in the atmosphere, and then they won't be a problem for the satellites anymore. It hasn't happened yet, but there's a lot of interest, and I think definitely in the next couple of years we'll start seeing some of these missions. Yeah, next slide, Dan. So yeah, that's basically what we do at the Civil Aviation Authority. Everybody in the UK who wants to launch or operate a satellite has to apply to us to get a license. Daniel and I, we review what they're proposing. So they might say, right, we've got this crazy new idea, that's new satellite, new rocket, it's never been tested before. It's never been seen before. We're the first people in the world to do it, and it's my and Daniel's job to talk them through that and go, okay, well, have you tested it? How are you sure that it's safe? How are you sure that it's not going to cause damage to the space environment? How are you sure it's not going to be dangerous for people on the ground? Because you try to put these rocket launches away from people as much as you can, but they have to fly pretty far, and sometimes they have to fly over where people might be, and you have to be ready for that. So the last thing I'll say is that Daniel and I both have quite a sciencey background. I mean, I was always interested in physics at school and kind of got into that route through this way, but I think it's worth mentioning that, in this job and in my career, we work with all sorts of people. We work with people interested in policy, we work with people interested in outreach, civil servants, people interested in finance, all sorts. There's a lot of jobs at the moment in space, and certainly in the last 10 years, it's really, really grown in terms of the scope of jobs that there are and the scope of just things that we're doing. And yeah, I just want to make the point that space is for everyone. And on the next slide, I've got a couple of links just for anybody who might be interested in career in space, or even just interested in some of the stuff that we've talked about. Spacecareers.uk is a website specifically for early career people in space. There's the UK Students for Exploration and Development of Space, which is a big volunteer group that runs a lot of space activities throughout the year. There's the UK ROC, which does the amateur rocketry that Daniel was talking about, that Daniel's heavily involved in. And there's also a National Student Space Conference that's run every year by UK SEDS. The next one's in Bristol. But if you're interested, I definitely recommend that. I went to it a lot as a student and I found it really, really helpful. And yeah, that's me. I'm happy to take any questions. We'll have a look at the chat, see what there is.
Thank you very much to both of you. That was absolutely brilliant. And space certainly sounds worse than the M25 on a busy Monday morning. So good luck with cleaning it up. Well, I can see that we do have lots of interesting questions in the chat. So I'm going to hand you over to my colleague Sophie, and she will put those to you.
Thank you, Lisa. So good morning to everybody. Good morning, Dan, Sam.
Morning.
So our first question has come through, and it's asking, so how much does it cost to send a satellite into space?
I can take that. I mean, the answer really is it depends. So on those pictures that I showed you, you have those small satellites that are about this big. They can cost, I mean, it sounds like a lot, but they can cost a couple of tens of thousands of pounds to build and design, and then put on the rocket. And that's, in space, that's pretty cheap. The James Webb Space Telescope, you're talking, hundreds of millions, if not billions overall, and that's over decades really of work and design to put that on there. But really, what the most expensive part is usually actually just booking the space on the rocket. Daniel, I don't know if you have any numbers to hand, but usually if you're building a small satellite, the building of the satellite is not the expensive bit.
Yeah, exactly. So I think a recent number I'd heard was around about £10,000 per kilogram of putting a satellite into space, which sounds about right. Which is, so it kind of makes sense. The bigger the satellite you get, the more expensive it's going to be. But yeah, in terms of the rocket, you're looking at about, for example, the rocket that you just watched launching, which is a small rocket. Now it's got a little bit of space in the top. You can get a lot more in there than just a little CubeSat, but you definitely can't fit the James Webb Space Telescope in there. But that's going to be around somewhere between £6 and £8 million for that launch. So that's quite a lot of money for that single launch. And yes, you might share that launch with many other satellites, so you can split the cost. But it's still quite an expensive trip, and even more than that, a lot of these satellites are insured as well, and the insurance cost tends to be quite high too.
Okay, great, thanks, Danny, for that. Okay, so the next question we have is there an apprenticeship that I could do at the CAA?
That's a great question. It's maybe not one for us engineers. It's maybe one for others in our team, probably Brenda, who might be able to get in touch to respond to that afterwards. I believe that the CAA do have opportunities like that. They do have STEM schemes where they're able to offer things. But in terms of the specific details, it might be best if we get those to you after the call.
Okay, lovely. And we've got a question, do you get to watch the launches?
So,
well,
yeah, unfortunately, I've never actually got to see a launch myself. We watch the live streams all the time. We're definitely interested, but yeah, no, unfortunately not. I didn't get down to Cornwall to see the UK launch, but I'm hoping to get to see one of the future ones.
Okay, great. And I've got a question here. What type of jobs will there be at the spaceports?
Daniel's probably better at that one.
Yeah, can do, because there's going to be a lot. So you can think of it as just like running any sort of processing or manufacturing facility, and there's going to be a lot of different jobs required. So there's going to be some that are very general, some which you'll just call kind of general spaceport jobs, and then there's going to be some that are much more specific to a launch operator. The more general ones are going to be things like making sure that buildings and appliances and the equipment are all going to be maintained, sort of lifting equipment, and there's going to be general deliveries for things like propellants, deliveries of parts. There's going to be things like people to check weather, to check local area, for monitoring the local area, making sure there's no people coming in. There's going to be security. There's going to be a whole host of things that are general to that spaceport. And then there's going to be specific jobs required for things that are really specific to the launch vehicle, that some experience in launch vehicles is going to be required. And that then gets split up over multiple different areas of the launch vehicle. So you've got avionics in the launch vehicle, so electronics. You'll need electronics engineers, people to test those electronics. You'll need propulsion engineers to have a final look at the engines and to test the engines. Static engine tests at the site, if they're necessary. You'll have managers, you'll have supervisors, you'll have people there for the satellite who have to do final testing on the satellite. So, but in general, you've got so many different types of people. It's not just the specific engineers on the actual rocket or on the actual satellite. You have all this these other supporting roles as well that are right down to cleaners in the spaceport. There's so many different roles that are required at a spaceport, and yeah, they're all open, available, and because spaceports are all in development today and they're all in construction, there's going to be a lot more of these jobs over the next 5 to 10 years, all coming up over these developing spaceports.
So there'll be lots of opportunities by the time our students have finished their education. It sounds like there will be a lot of opportunity to work at these spaceports, which is great. Okay, so the next question I've got from somebody is, how far away from a launch do you have to be?
I'll maybe take this one as well. So that again completely depends on the size of the rocket. Depends on how many people are around. But I mean, generally you can think of it as being sort of 1 to 2 kilometers, somewhere in that region. Maybe slightly more if it's a bit of a bigger vehicle. The types of ones that you get in the US, this is the difficulty, right? Because if you look at the US, you have a huge land. You've got lots of space. You can go out into really the middle of nowhere, and the middle of nowhere being there might be somebody that's 15-20 miles away. You have such a vast amount of land, and in the UK, if you look at us on a map, actually we're very small, and we have a heck of a lot of people here too. So it's quite hard to actually find a location that there's nobody around. And generally, what that means is you're going to have to tell people to either leave their houses or please don't go to your farm that day or something like that, because there's just not a lot of space. So even the ones up the very north of Scotland, in Shetland, in Sutherland, out the Western Hebrides, these areas, they still have people around. So yes, that doesn't mean that you just let people be in their houses really close to a launch when it's happening. Of course not. Public safety is our key role. But it does mean that the UK has adopted an approach where we don't just give a license to an operator if they say we're going to put them 2 kilometers away, and then that's it. We go through something called risks have to be reduced to a LARP, it's called, so as low as reasonably practicable. And that's just a fancy way of saying the operators have got to say, okay, my people are at 2 kilometers but away from my launch, but I can't put them any further. If I put them further, then these are all the problems that I've got. I've got lots of houses beyond there. I've got this and that and the next. So the operator's got to justify why they can't make people go any further away. If those people can't go further away, then that's fine. They've done their job, and then we have to make sure that we're happy with that. So yeah, but the short answer is typically you can expect probably a couple of kilometers to be away from the launch.
Okay, great. Thanks, Dan. So I think we've just got time for one more question. So the final question is the UK working on more sustainable ways to send satellites into space?
I can take that one. If I'm live, yep, there we go. Yeah, so I guess ultimately that's kind of what our job is. I mean, as a regulator, we were stepped up just over 2 years ago now. And I think our approach is definitely a lot more hands-on than it used to be. And one of the things we look at is making sure that when these satellites are launched, that they come down within a certain time frame, so they're not up there for years. clogging up the orbits. So yeah, in that regard, we definitely are looking at more sustainable ways, but people are always looking at new ways of making space more sustainable, new ways of getting things down earlier. When I talk about sustainability, I talk about sustainability of the space environment. In terms of environmental sustainability, that's another question. I mean, that's another thing that we look at, is what is the environmental impact. I'm not quite sure which part of the question was referring to specifically, but yeah, we're certainly looking at more sustainable ways of doing it. And yeah, I think on a global scale, we all realize the importance of keeping these orbits sustainable.
Okay, great. Thanks, Sam. Thank you so much for both of you for answering those questions, and thank you to everyone who's been watching and putting the questions in the chat. I'll just pass over to my colleague Lisa now, who's just going to finish off.
Thank you, guys. That was really, really informative. Such an interesting webinar, and I'm sure our audience will be inspired to learn more about careers within the aviation aerospace industry. I have put the link into the CAA's career programmes, but as mentioned in the chat, Sophie will send out all the links post-event to you so that you have everything to hand. But thank you very much, guys. Thank you for joining us, and enjoy the rest of the World Space Week. Goodbye, everyone.